Hey. The debate today at lunch is going to be about stem cells. Brace yourself. Stem cell. S-T-E-M space C-E-L-L. Stem cell. If you've been around anywhere in the last 20 years in science or media, you've probably heard of stem cells because they are not only a biology word, but they are now a word very relevant to ethics and law and, of course, to engineering. And I would say that they're relevant to engineering in two huge ways, despite it being a biology term first and foremost. Well, a stem cell, as we know, is a special part of organisms, including humans, that is basically in fetuses or young organisms. And then when the organisms grow and develop, those stem cells can also grow and develop too into various types of cells. I think some people call stem cells like the mother cell or something. It's like this undifferentiated, that's the term, undifferentiated cell that can be almost anything. Which sounds a little poetic now that I'm saying that out loud. But the reason why it relates to engineering is twofold, as I said. One is that there's tons and tons and tons of engineering used to even analyze stem cells. We only know what stem cells are because of engineering. I mean, we need to engineer microscopes and engineer bioreactors or engineer incubators or engineer extraction tools. There's all these tools that we need to use to look at and understand what stem cells even are. And that's pretty amazing. So regardless of where you may stand on the morality or ethics of using stem cells, there's definitely a lot of cool engineering being done to at least know what stem cells are. The second huge reason why stem cells are an engineering word today, and arguably the more fascinating and interesting one personally for me, is that stem cells are also a tool of engineering themselves. So you got that? We use tools to analyze stem cells or to build stuff around stem cells, but we also can use stem cells now for the purposes of building things too. What does that mean? Well, stem cells are undifferentiated and they grow into other things. So if you put stem cells in the right environment with the right chemical stimulations or electrical stimulation or whatever, well, you can make something new with them. You can make an artificial organ. Or is it really artificial if it's made from stem cells? You can maybe use stem cells or have them differentiate or develop into certain medicine-producing cells. Maybe you can use them to grow limb transplants. I mean, there's a lot of potential for human good with stem cells, and possibly bad, just like with a lot of other technologies. And so moral ethicists and philosophers definitely, I think, should get into that debate about stem cells so we don't create some mad scientist, six-legged villains that will ruin us all with stem cells. And instead, we cure cancer, or we replace limbs, or we cure mental illness. I mean, there's all these possibilities. Stem cells, or stem cell, is our engineering term of the day. Hi there, this is Pius Wong, producer of this podcast and producer of the K-12 Engineering Education Podcast. If you're into what you've been listening to, and if you're into engineering or education or some combination of the two, go on over to www.k12engineering.net to find out more about what I'm doing. Thanks for listening.